Hi, my name is Stephen Fluin, and this is Demos with Angular. Today I want to dig into one of the things that I've been really excited about recently, which is this idea of building an Angular application with an entire backend and API layer baked into the same project. Under the hood, I'm using technologies like Node, Typescript, and Express, and I'm doing this in a cohesive way so that you have a single code base that serves both the front end of my application and the back end. Let's take a look at some of these best practices. I am starting today with the usual setup here, so I've created a new Angular project and I've got it serving in the background. So this is just a normal default CLI project created from the terminal. So let's take a look at the plan that we're going to be following today. So today I really want to go ahead and create a server folder in my CLI project. This is going to be where we're going to put all the configuration, all the files that are going to run on the server side of our application. Then we're going to do that via setting up some of the dependencies on things like TypeScript and some of the tooling. Then we will do add routing. So we will use Express and we'll actually respond to different API calls in different ways. So we've got a bunch of things we're going to do in the future, but let's come back to those. So we can see here we've got a normal Angular project. And what I'm going to do now is I'm going to create a brand new folder at the root level. So one of the things to note is that there's lots and lots of ways of doing this. Obviously, everyone's going to have their own preferences, everyone's going to have their own technologies, but I have done this on 2 or 3 projects now, and I'm really happy with how this looks and feels, and you get a mono repository that has all of the client-side code in an Angular application and the server-side API for running it all in one place. And so it's actually very easy to tool, very easy to manage. And so server is going to be blank by default, and what I'm going to do is I'm going to go ahead and cd into that folder. And we're going to create a few files here. So the first thing I'm going to do in this folder is I'm going to go ahead and create a package.json. So I'm just going to run npm init, give it all the default options just so that we get a nice file where we can add some of the dependencies. Now I'm going to go ahead and add the dependencies we need to actually run our application, to run the server-side interface. So I'm going to yarn add, let's add ts node, something called ts node dev. I'm going to add tslint so we get nice linting, TypeScript so we have our own version of TypeScript, and then let's go ahead and add Express and add types Express, and then I think that should be good. We'll come back and add any other dependencies that we might need. So this should all be added into our new package.json. This is going to be what we're running on the server. And now I'm going to go ahead and create a new file in that server folder, and I'm going to call it server.ts. Now, by default, this server.ts file is going to use the same tsconfig as the rest of our application, but I actually want to give it its own tsconfig. So I'm going to run tsc --init, which is going to create a basic tsconfig.json file in this folder that will apply to all of these projects. And I'm going to turn off strict because I find it's a little bit too powerful, too strong. But obviously you can change all of these things to whatever extent you'd like. And just to make sure that everything's working here, let's do console.log, hello world. Save this, and then let's go ahead and run, instead of running node, I'm going to run something called tsnode, and then I can just run that directly on server.ts. So this works because I've got tsnode installed globally. You could run this from your node module /bin folder if you wanted to. But now that we actually have this working, we've got TypeScript hooked up, we're running our TypeScript file, let's actually go ahead and add this to our scripts file. And so I'm going to create a script here. Let's call it serve. So scripts, and we're going to give it a key of serve. And then I'm going to run tsnode dev on our server.ts file. So tsnode dev, it's just like NoDaemon or NodeMon if you've ever used that tool, in that it creates a live kind of watcher of your TypeScript files and then automatically reloads as you make changes. We already have a scripts file. Whoops, messed that up just a tiny bit. Let's just move this back up, add a comma, and then we can get rid of the bad version here. So we've added that into our package.json. Let's go ahead and run yarn serve and just make sure this is working. Perfect. Hello world's done. Obviously, it's not watching the changes and it's not continuing to listen because we are not actually executing the script over time. It's just kind of synchronously finishing. One other thing that I can do to make my life a little bit easier as a developer is I can go to the parent project. So we're going to leave the server folder now, and I'm going to add something called concurrently. So I'm going to yarn add concurrently. And what concurrently does is it's able of running two scripts at the same time using Node. And so what we can do is now we can modify the parent package JSON. And let's say we want to do both serving of the client and the server all at the same time. So what I can do is maybe make a serve command here, and then I can run concurrently, and then I'm going to do a couple commands here. So I'm going to do ng serve, which is just going to run the normal serve for my Angular CLI project, and then I'm also going to run the ts node dev from the parent. So I'm just going to go node modules.bin ts node dev server.ts. Now, one thing you're going to note here is that we've got a set of quotes on the outside, but we actually need quotes around each command. So we're just going to have to just add these in here and escape them. All right, so concurrently, whenever I run yarn serve, I'm going to get ng serve from my client, and I'm going to get this server running. So if we run this, let's go ahead and spun up a server in the background. But now, from now on, I'm just going to run yarn serve instead of ng serve. So the server did not quite run correctly. I'm not sure why that is. We'll take a look in a second. As well as we're getting the wrong version of TypeScript. All right, I see our ts node dev here, so let's just double check that we've got server node module. There we go. That would be why. Yarn serve. Let's give this one more try. So we should see our hello world, and we should see the Angular CLI coming up. Hello world, there it is. All right, so we are in action. We have now successfully built a client side and a server side that will operate at the same time. So next what we're going to do is we're going to go ahead and add Express into this main application. So let's go ahead and just close almost all of these. So I think we can just close to the right. And we're going to go into our server.ts. So I like building servers with Express. So what I'm going to do is I'm going to go ahead and start off by importing Express. So the way you can do this in TypeScript instead of using require statements is you can import star as Express from Express. And as long as we have this in our node modules, that should resolve. I've also got a VS Code extension that grays out imports that are not used to help me out. And what I can do is this is just standard Express code. So I'm going to say app equals Express. Now that I've got the Express server, I'm going to actually go ahead and use this. I'm going to tell it to listen to port maybe 4201, and then we're going to bind that to localhost. And then what I like to do is I like to give it a callback function that just lets me know that the server is listening. Oftentimes when I get into more robust server setups, obviously this will be an environmental variable, and then I'll be rendering out kind of what mode the server is in and where it's listening. So if we take a look now at our console, we should be seeing server now listening on 4201. We're seeing that it's automatically restarting whenever I visit it. And now we can actually go to 4201 here. Cannot get blank. So we're getting a 404, which is perfect because this route doesn't exist. We're not actually responding to it. If I went in and I built out an app.get of the root route, and then I defined a route here with a request and a response, I could use that response.send, maybe just an empty JavaScript object. And then when we hit this server, we're going to see that empty JavaScript object. And so let's actually give it a response here. So we've just got a very, very simple object. But now let's go ahead and set up our client, which we should have at the same time here. So before we can actually access our API, we need to deal with the problem of cores, because we're requesting data from an API that is not on the same origin or the same host as the server. So oftentimes you can get around this by hosting on the same port, so then we can actually have our Express application proxying to the distributed or built application. This is one of the things I sometimes do in production, but it's relatively easy to add the appropriate cores header. So we can just do app.use, and then we're going to pass it a method that's going to take a request, response, and a next. And then what's going to happen is I need to add headers to that response. I'm going to say response.header, and we'll add a header for access control allow origin, and that's going to be any origin. And then I'm going to add a response header for access control allow headers. And there's going to be a bunch of headers that I'm going to respect here. So origin, x requested, width, content type, accept. And then finally, I want to allow different types of access. So not just get. So we're going to say access control allow methods, because if we're going to be building out a RESTful API of any kind, we want to make sure that we allow things like posts and puts and deletes and all those somewhat standard options. So options for the pre request, get, post, put, delete. And now what we're going to do is we're going to allow options here. So we can do something like if options equals request.method, then we can say response.send status 200. Because if a options request is coming in, I don't really care what it is. I just want to say, yes, we allow these sorts of types and not run any of the code twice. But if it's not an options request, then we actually want to do something. So we're going to say next here. And one of the things I like to do is I like to, again, console.log out some of the information about this request. This makes it easier to debug later. You can set this up into a more robust server. So maybe here's the IP the request came from. Here's the method of the request, and then maybe the final request that URL. So that as you're debugging your server, you can always understand kind of what API requests are coming in at what time. All right, now that we've built out the course header responses for our server, we can actually jump into our client-side application and now listen for that message. So first I'm going to jump into the app module, and we're going to import HTTP client module here from @Angular common /HTTP. And then we'll go ahead and import this module, which allows us to make HTTP requests. And now I can go into my app components code here. We'll go ahead and import HTTP client from the same place. And I think it might actually even know. Nope, it doesn't know where it is. @Angular common HTTP. And I'm going to set that up in dependency injection for my constructor. So we're going to say private HTTP of type HTTP client. And then let's go ahead and define an observable called messages. So messages is going to equal this.http.get. And we know we're going to get back an array of type any here. And then we will pass it a path. So our path is going to be HTTP localhost 4201. And then that should be good. So now we have an observable that emits arrays. And now we can use our messages here on our component for HTML. So just blank out all the text in our app component. Now I can do something like div ng4 equals let message of messages pipe async. And now we'll say message.message. Because I think that matches the shape of the API we're expecting. So let's go ahead and take a look at our app. If we refresh our server, let's make sure our server is working here. So that does seem to be coming back successfully. Now let's take a look at what's happening on the client side. So we've got this messages that is defined as part of the component, and it helps if you save the file. So now we have an observable here. Let's clean this up a tiny bit. And then we are now seeing our hello world. So you could put a header on this if that was helpful to you. So you could say like messages, and then this could be, instead of a div, you could make this maybe like an ordered list. And then instead of a div, this could be an li. And you can kind of just see how the data is coming back and how it's being presented to the user. So the final thing I want to do is I want to go into my server because one route is not actually very helpful. I actually want to create a set of routes. You could just follow the standard kind of architecture of Express and lay this out however you want. I could create as many routes here as I wanted to, just give them each different paths, those sorts of things. But one of the best practices I like to do is I like to create a routes file. And so let's go ahead and do that. So in my routes file, I'm going to go ahead and say import stars express from express. And then I'm going to say const app equals express.router. So this basically gets me a copy. I'm creating a sub router that we can then delegate to from the express file. So let's call this routes.ts in our server. And then what I can do is I can say export app as routes. And now here I can go ahead and define as many routes as I want. So I can say for the basic site, let's go ahead and do that Hello World app that we had here. We can also do things like app.use, and we can create different routes for different parts of our site. So maybe there's a user's route, and then I could do the same thing I'm doing here with a nested router. I could pass that off to the users here, but we'll just make this a GET request that responds with an empty array for now. So you can see we can create as many routes as we want here. Using Express, you can do things like app.post, and then I could say, like, maybe this is, you wanted to create a user. So obviously you just create the routes however you want them to. One of the things I've done here though is I've allowed a post request here. And so obviously you want the data from that post request. And this is actually relatively straightforward as well. And so what we can do is, let's say here we just return back the request.body. So built into the Express server now is the ability to actually process the data that's coming from a Angular request. And so let's add, we've got our app use here for the CORS headers. Now let's add one that says app.use express.json. And so basically what this does is it says any data that's coming as part of the request, as part of the post, as JSON, that's going to get added to the body of our request. So now if we go ahead and we wire up a button in our Angular application, so let's just say button click equals post. And we'll just call this create user. Obviously, we're not going to build out any of the functionality. And now we are going to go ahead and create that post method. So what I'm going to do is I'm going to say this.http.get, actually a post, excuse me. And then we're going to say http localhost 4201/users. So this is a theoretical HTTP request where we're creating a user. And then what I can do is I can say, this isn't actually a response. We would just want to subscribe to this. So let's say .subscribe. And we'll just post out whatever data we get back. And this could be of any type. And it wants the data. So let's say username is Steven and password is Steven. Obviously that's not my real password. So what we should be seeing is whenever I click on the button, we're going to send an HTTP request to /users as a post, and then our server should be listening for that post request and sending it back. So the only other thing I need to do is to make sure that I actually wired up these routes into our server. And so what I can say is we can say import routes from our routes file. And if we want to go ahead and use this, we're going to say app.use routes. And we'll just wire this up to any request. We'll get rid of these because we don't actually need them anymore. And we should be good to go. Let's take a look at our work. All right, on the server, we have a new hello world that we built as part of the subroutes. If I get users, we should now see an empty array. And if I click this button in our experience, I should be making a post request to the server, and we're getting back exactly the data that we sent in. So we've been successful. So just to recap what we did, we took a base Angular application, we added in a server folder, we set up that server folder with the appropriate dependencies to let us build things in Node. We set up a TypeScript configuration so we could do things a little bit differently on the server. And then we built out a tiny little Express server using TypeScript, using these import syntax. We wired that up into our Angular application to actually test out a couple of these routes. And then we started building out the content of our real application. So hopefully that made a lot of sense, and I will see you on the next one. Thanks.